very common question. We know something about the past. Apparently, we had a beginning. That was what we call the Big Bang. How about the future? Would the universe expand indefinitely? Is it going to keep expanding and at some point collapse? What's going to happen? Now, I cannot tell you with certainty what's going to happen, but we have some reasonable guess, but it's based on some extrapolation from what we know. And I have to go back to this diagram that I showed you before. You remember this? The Hubble diagram? I actually lied a little bit when I told you about this diagram, right? Each of these is a supernova, and I told you the further away something is, the larger the velocity, meaning the distance and velocity are just proportional to each other. If it's strictly proportional, the supernova should basically lie on a straight line. Yeah? Of course, modern measurements always have error bars, so there are these error bars, so you should take that into account. But nonetheless, these points accounting for the error bar should fit just a straight line. But if you go far enough out, do you notice that these supernovae, which are very far away, very faint respect to us, they are actually not on that straight line? Do you see that? They are not on that straight line. And one wonders why. Why is that? And that actually has a simple explanation, because you see, if you look at objects that are very far away, like these supernovae, they are very far away. The light from those supernovae took a long time to reach us, right? So it means these supernovae, they reflect the expansion of the universe a long time ago. Not today, but a long time ago. And the expansion of the universe, the rate at which it expands could change with time. Okay? And in fact, based on the fact that the way these points are off that straight line, we find something actually a little bit startling. And let me see if I should explain that to you. Yeah, I think let's go through it. It will take a little bit work, but I think it's okay. Let me try to explain to you. So the starting fact was this. Let me just tell you the conclusion, and I'll try to tell you how you see it from this diagram. So astronomers, based on studying this, they were able to conclude that the universe expansion back then, when we see this supernova, was in fact slower than it is today. So it's as if the universe expansion is speeding up with time. Okay? And it was a big shock. Why? You know why it's a big shock? It's a big shock because gravity is attractive. Yes? In other words, gravity sucks. So if you have something that's expanding, gravity would like to pull it and slow down the whole expansion process. Yes? Because all the galaxies, they are attractive towards each other. So as they fly apart, the gravitational pull should try to slow it down, not speed it up. So it was a big surprise when these astronomers in the late 90s, there were two teams, this is one of the team, and this is the other one, when they discover that contrary to expectation, the universe expansion was speeding up. Let me put it in another way. It's as startling as the following. You all have the experience of throwing something into the air, right? So let's say I throw a piece of rock into the air. As the rock moves up, we all know it's going to slow down. Why is it slowing down? Well, because the Earth's gravitational force is pulling it back. That's why it's slowing it down. So to see that the expansion of the universe behaves this way, where it's speeding up with time, would be the analog of saying, I throw a rock and it just keeps flying faster and faster away from me. That's very strange. That was a big surprise. Okay, and it was this surprise that led to these two teams. I think about 5 years ago to get the Nobel Prize. It was a big, surprising discovery. But before I tell you a little bit about the explanation. Let me tell you how do you see this fact that the universe expansion is speeding up just from this diagram, okay? It's going to take a little bit of work, but I think it's okay. Let me go through it with you, okay? So suppose I'm interested in a supernova that is at some distance away from me. So I'm going to draw a horizontal line. Any object that is on this line would be at a known distance, at a fixed distance away from me. You got that? Okay. Now, if the expansion rate were constant all the time, then you should really expect a straight line, like so. And if you ask at the distance that you're interested in, where are these supernova with respect to the straight line extrapolation, they are a little bit slower. Does that make sense? Should I explain that again? So if you draw a horizontal line, let's say I'm only interested in supernovae at a given distance, and if I draw a straight line from basically these nearby supernovae, I find that on average, those supernova at the distance that I'm interested in, they are on average at a slower velocity compared to the straight line extrapolation. That is a sign that the universe back then was expanding slower than it is today. Does that make sense? So it's purely an effect that these supernova are a little bit above the straight line that you would naively expect. That's it. Okay, that is worth the Nobel Prize of these two teams. Okay. So let's talk a little bit about why is the universe expanding in this strange way. There are many explanations.